Alrighty, chemistry students, the purpose of this video is to give you a brief overview of what a quantum number is. It's going to be confusing, it's going to be a little tough. Just know the basic understanding of the different quantum numbers, and we're going to talk more about this as we go into electron configurations again as well. Okay. So just the basic definition of a quantum number. A quantum number is, it specifies the properties of atomic orbitals and the properties of electrons in those orbitals. Okay, a quantum number is used to describe the movement and trajectories of electrons in an atom. Okay. So there's different types of quantum numbers. There's 4 different quantum numbers we're going to discuss, and the first is the principal quantum number. The principal quantum number is symbolized by the letter N, and it indicates the main energy level that's occupied by an electron. So basically, this principal quantum number is telling us the most probable distance that an electron is from the nucleus. It's telling us which shell it is in. So for instance, if N was 1, our electron is located somewhere in that first orbital, first shell. If it's N3, it's somewhere in that third shell. And you've seen these shells in your POGIL. We know that we have N1, N2, N3, N4, and 5. And so depending on what the N is dependent upon the principal quantum number, and it tells us the main energy level that something is in. If you have a larger N, it's further away from the nucleus. Our next quantum number is the angular momentum quantum number, which is symbolized by the letter L, and it tells us the shape of an orbital. Okay? So, if L is equal to n minus 1. So for instance, if we had n was equal to 2, then our L value would be 0 and 1. So L can be equal to 0, and these different values of L mean different things. Okay, and I'll draw them here since they're not on our slide. So let's say n equals 3. That means our principal quantum number is 3, so that we have 3 energy levels. If we have 3 energy levels, remember L is equal to n minus 1, so our L could be 0, 1, or 2. Our quantum number is 0. Oh, it went away. When our quantum number is 0, this tells us that we have an S-shaped orbital. If our quantum number is 1, it tells us we have a P-shaped orbital, and I'll show you more what this means in the future. And if we have a 2 L value, it means we have a D-shaped orbital. D as in dog. There's also a possibility of having the 3, which is an F-shaped orbital. And again, we'll talk about more about this when we talk about electron configurations, and you'll see what these look like and what the shape of them are. Our next quantum number is what we call the magnetic quantum number, and it's symbolized by the letter M. So this is telling us the orientation of an orbital around the nucleus. It tells us how something is spinning. Okay? M is is any value between negative L to positive L. So again, let's go back to our last example. If N is equal to 3, see, I wasn't drawing, I was skipping slides. So if n is equal to 3, that means our L can be equal to 0, 1, or 2. My 0 didn't work very good there. And that means our M can be equal to negative 2, negative 1, 0, 1, or 2. These are basically just showing if an orbital is going to be upright, if it's going to be on the z-axis, if it's going to be on the x-axis, and what orbital or what orientation it's going to be. And then lastly is the spin quantum number. The spin quantum number only has 2 possible values, +1/2 or -1/2, and it indicates the spin states of an electron. So electrons are always going to pair up, and one is going to spin one way and one is going to spin the other way. If it has a +1/2 value, it's spinning forward or spinning up, and if it has a -1/2, it's spinning down. I do have an extra little video here that I want you to watch. If you are still confused, we again are going to go over more of this in the next couple days of class if you are confused. I just want you to know what those 4 numbers are and what they mean. Thank you.